One hydrocarbon with this formula produces two hydrocarbon molecules as products in the process of cracking. Now, each of them contain the same number of carbon atoms. That means the starting hydrocarbon molecule must have an even number of carbon atoms. So I have A, B, C, D, 4 answers. A and D, odd numbers. Let's rule out these two. They are not the answers. Now we're only looking at B and C. So B, if the starting molecule is a hydrocarbon with 6 carbon, C6H14 became two molecules with the same number of carbon atoms. So that means 3 carbon, 6 divided by 2, right? C3H8. The other one will be an alkene, C3H6. So the cracking of hydrocarbon and alkene will produce an alkane and an alkene because we do not have enough hydrogen atoms to form two alkenes. So the product is always one alkane and one alkene. C3H8, C3H6. Let's look at C. We start with C8H18. One alkane, one alkene, same number of carbon atoms. So the alkene will be C4H10. The alkene is C4H8. So let's look at the last sentence of this question. Each hydrocarbon product has non-cyclic structural isomers. Okay, non-cyclic, so they don't join together like this. They are aliphatic isomers. I'll now draw the structure of C3H8, C3H6. If you look at the structure of these two alkane and alkene, they will not have structural isomers because they do not have enough carbon atoms to have branches. So these three carbon alkane and alkene will not have structural isomers. We move on to these two 4 carbon atoms, alkene and alkene. These are their structures. Can they have structural isomer? The answer is yes. Let me draw the first structural isomer of C4H10. The first structure that I draw was butane. The second one that I draw in blue pen is 2-methylpropane. These two are structural isomers of each other. So C4H10 has structural isomers. Now, I'll draw a few structural isomers of C4H8 and alkene. The first one that I drew was but1 in. We can draw but2 in. This is but2 in. Let me draw another structural isomer of C4H8. This is another structural isomer of C4H8, 2-methylpropene. So our answer is C.